1.
Everyone, welcome. This is Team 6 Phantasos, and this is our final video presentation. Connor, take off.
For our project, what we wanted to do is revolutionize the ways that people can interact with their computers. We did that in two ways, with an eye tracker and with an armband.
Seriously, these things, they're outdated. I don't know how you guys are okay with using these in your day-to-day lives.
Oh, come on. And let's go!
Hello. Today I'm going to be demonstrating the functionality that we have for the eye tracker. Me and Rodrigo have been working on this for the past year, and we feel like we've actually developed some stuff which is useful and really helpful for a variety of audiences. What I wanted to focus on with a part of my project was I wanted to basically help developers become more productive. So one of the things that is common among developers is to use the mouse less and use more keybinds. So what I was able to do is basically using eye tracker data we get, I was able to develop an autofocus type application so that if you want to, you can just autofocus onto whatever window you're looking at. So as of right now, I'm focused on the terminal, and we can run a Python file, and basically it works as intended. Now with a simple keybind, I can just switch over to the Vim window on the other end, and then hit insert, and we can insert whatever we want, like print stuff for demo, and just write it. And then with the same keybind, we can just look back at the terminal and then run the same thing, and as we can see, I've successfully updated the file and switched windows back and forth, all without leaving the keyboard. This is a nice functionality just to help improve people's ability to work in whatever environment they choose. This works with pretty much every window except for a few strange ones, where basically it allows you to auto switch the focus to wherever you want to look, and it's really good. One of the things that we did want to do is also increase usability by basically saying Alt-Tab, and from this you can see that the Alt-Tab focus is following my eyes. So if I look at File Explorer and select that, then the File Explorer is pulled up, and then you can start working with that. Go back to Alt-Tab, and we can select whatever terminals that we want and select those focus, all without using the mouse at all. This is really useful functionality, and is actually kind of intuitive and fun to use once you get used to it. It's interesting. The next thing I wanted to demonstrate was the aim assist. So one of the things you might notice now is as I'm moving the mouse around, it can occasionally jump towards the center of the screen, and that's because I'm looking at the center of the screen, and anytime I move the mouse towards the center of the screen, even slightly, or towards where I'm looking more specifically, it'll automatically jump to move to that location. Now what this means is that in a video game, we have really nice functionality in that it increases the performance of a gamer, and that they are able to move with better accuracy and basically aim down sights and move quicker, all things considered. I was actually able to test this functionality with my roommate, and we observed on the order of about a 20% increase in his aiming abilities while using the eye tracker. It's not functional currently on all games, but with the games that it is functional on, it works very well, and with a slight bit of tweaking in the actual code base and how it detects mouse movements and how it actually changes the mouse. We believe that we'll be able to get it working in all games and be a toggleable configuration, so if you wanted to turn off auto aim, it'll basically be turned off, and then you can return it on if you want. But that's the functionality that I had: the automatic window focus, the automatic Alt Tab, and also as well aim assist in video games.
Hi everyone. As Carter mentioned previously, so we decided to build two separate eye tracking modules in order to get more functionalities done in this short period of time. And as you can see, this is the user interface for my module. And we have here two main functionalities, which are scrolling and zooming. So we're able to scroll up and scroll down according to where we look at the screen. And we are able also to zoom in when we get closer to the screen. So when a user first tries to interact with this application, we have to calibrate it. For the calibration, the screen gets divided into different sections, so you have to look at the color section for a while. And all this data is sent directly to a Python script, which has a machine learning classifier, which is later imported into our main C++ program. Now here we have to get closer to the screen, so the sensor can measure the proximity to the center of the screen. And it should be done any second now. Perfect. So now, for example, if we turn on the zoom function and we can control here, for example, the zoom factor, we see how it gets zoomed in and how we can pan around according to where we look at the screen. We can, of course, adjust the zoom factor, and we can, for example, scroll down. If you go here, for example, to Visual Studio, you see how it's scrolling down. If you turn on the scroll up, for example, you see how I'm looking at the top section of the screen and we're scrolling up, and we can adjust actually how fast we scroll at once. You see it's much faster. And here, for example, you can control also how many lines we scroll at once. Oh, yeah. And yes, for example, and each user can adjust this to whatever preference. And you can see that this actually works for several applications, like reading a website, and we can, of course, like zoom in. We can do it also, for example, if we try to read the files we have in the computer, or, for example, a PDF we're reading.
Many computer games require the user to press various keys on the keyboard to move or interact with the game. One thing we thought would be cool would be to use the GeForce Pro armband in order to replace these movements. The GeForce Pro armband records quaternions, which contains information about the axial rotation and position of an object. In this example, in the Google Dinosaur game, I coded a program that allowed the user to play the game without clicking the spacebar. Instead, by rotating your arm to the left, the space key is pressed. More complex games can also be played using quaternion data by mapping other rotations and movements of the arm to other key presses. In this game, which resembles games like Temple Run, the arrow keys can be replaced by the armband. Here I encoded the left arrow as rotating my arm to the left. The right arrow key is equivalent to rotating my arm to the right. And finally, the up and down arrows are pressed by flicking my arm up or down accordingly. As you can see, this makes it possible to play these sorts of games as well.
Quaternions are not the only thing that this armband can measure. This armband also functions as an 8-channel EMG, which means that it can measure the electrical activity of my muscles. This is cool because you can see that as I'm making different gestures, it's actually flexing the muscles in my forearm differently. So if we collect this data and then pass it to some model that can then be used as a classifier for what gesture I'm making, we can do all sorts of cool control things with macros, programs, just any sort of computing interface. You can see that as I move my arm in different ways and make different motions and gestures with it, it's all changing the waveforms in different ways. So now let's move on to see a few cool demos of what this can really do. If I wish you could have a bit more of a streamlined debugging experience, it's now as simple as highlighting and to Stack Overflow we go. Do you ever just get a lot of annoying emails and don't want to have to read and respond to them? Well, with this armband, now you don't have to do that. With a simple gesture of my arm here, we can see that this email gets automatically taken care of without me even having to look at it. Likewise, another email pops up. Well, that's just another wave of the hand, and before you know it, that email is taken care of as well. Very efficient. The armband can also be used for a little bit more simple tasks like navigating your web browser. With a simple gesture, we go back a page. We do that again, go back, and let's do that one more time. There we are.
3, 2, 1, go.
So as you can see, these are working prototypes we have for our project. In the future, we want to expand on it by giving more platforms for different games and adding different things that we can do with the eye trackers and armbands to include more gestures to make the overall user experience better and more fulfilling.
Thank you so much for watching Weird Team Speaks Phantasos. Have a nice day.
Thank you.
Thank you.
Alright, and cut.